circle. This is minor sector, this is major sector, this other is major sector. There can be major sector, minor sector, and half semicircle can be the two equal sections, equal sectors. I mean, because two equal sectors can be there. There are two semicircles. So here AOB is a sector, which is a minor sector. Which is a minor sector. But if I take this whole arc BA, then BOA, you can say BOA is a major sector. Minor sector and BOA is a major sector. Is a major sector. Now this area, perimeter, everything we will calculate in other. Lecture series. Next lecture series. This is sector about area of this is just a part of the circle. If I divide by this, theta is the angle multiplied by, okay, this is theta into 1.2 r square, radius square. Theta is the angle here. Whatever angle given to us, that will give us the area of this. Now what is a segment? Segment is when a area of the circle which is below the chord. The chord is the area lying between the arc and the chord, known as segment. This is a segment here. Okay, this is segment. Which one? If I take a point here, that will take this is you will see here. C point is lying on this line, straight line. Okay, so segment is the section of the circle, okay, line between the chord AB, in this case let me take AB, and the arc AB, and the arc AB and chord. The area, so there are two major sections of this. This is minor segment, this is major segment. A circle is divided into two segments, minor segment and major segment. Again, minor segment, this is major segment. And the area of this can be obtained by taking area of the sector minus area of the triangle OAB. The area, this is the area of this. You can find out area of the segment. Area of the segment is equal to area of the sector. Area of the sector AOB minus area of the triangle. Area of the triangle AOB. Again AOB. This is area of the triangle. From sector's area, if I subtract area of the triangle, area of the triangle AOB. If I minus the area of the triangle and from the area of the sector. Now sector's area includes between the arc and the two radii, total area, segment and plus area of triangle. If I subtract area of the triangle from the area of the sector, we will obtain the area of the segment. So that is segment here. Okay, so segment is a smaller portion of the. This is about circles, common tangents, okay, and direct common tangents, indirect or transversal common tangents. This is what we have talked about. Now let's take 12th question. The last question is 12th. Let me now talk about question number 12. Now something about, okay, question 12th is, which are the conic sections? Now let me talk about some conic sections. Before that, let me clean this. Now conic section is a part of coordinate geometry, but here I am taking for the closed figure, ellipse is there. So area of that closed figure will be required in case of sometimes in some competitive examinations. Coordinate geometry is also asked. So in that conic section is very important. That I'll take separately even. Okay, questions based on conic sections I'll talk about separately, but today I'm just brief introduction, definitions, and what are the conic section, definition of them. Let me just talk about them. Okay, what is the formula for them and how to draw a conic section. The conic section, by the way, why they are known as conic section. Now if I take this is question number 12 here, conic section. I have taken this. Okay, let me take and just mark. Okay, so conic section. This is known as conic sections. Sorry, not sectors but sections. Conic sections. So simply conics. They are known as conics also. Simply conics. So if I slice. Okay, let me draw two straight lines like this. Now, this is a cone. The two cones are obtained. These are two nappies of the cones. This is and the nappy of the cone. This is O point here. Let me take AB. This is CD. Now, if a plane like this, let me take this as a plane here. Now, if this plane is intersecting or cutting a part of this nappy one, then we will obtain a conic section. The section which is obtained is known as parabola. Okay. Now let me talk about why they are conic section solution. If a plane cuts of a plane figure, let me take the plane area. If a plane area cuts a nappy of a cone, okay, then and it is parallel to the generator, and the slicing, let me take, and the slicing plane is parallel to the generator, other than the vertex. This is vertex of the cone, other than cone vertex. If I cut here at the vertex, no conic section is obtained. This is to be plane to the generator. Okay, so this plane area is cutting the slice of the nappy of the slice which is cut. The slice, okay, cone and the slicing plane is parallel to the generator. Okay, then the section obtained will be a parabola. Section obtained will be a parabola. One thing. Secondly, and why this is conic? Because this is section of the cone, a part of a cone, because they are known as conic sections. It's a conic section. Parabola is obtained here. If the plane, okay, cuts the cone, the two nappies of the cone, the two nappies of the cone, two nappies of the cone, and the plane is not parallel, and the plane is not parallel to the generator. is not parallel to the generator. If it is not parallel to the generator, then it is a hyperbola. Cuts the two napies of the cone and is not parallel to the generator. Then it is a ellipse. Okay, if it cuts one and it's not parallel to the generator, then it is ellipse. It cuts both the napies, two napies, and okay, then it's a hyperbola. Plane is not parallel to the generator, then it is a hyperbola. And if it is not parallel and it cuts the one nape only, okay, a single nape, then it is an ellipse. That is ellipse, hyperbola or ellipse. In case of ellipse, it is not parallel. Okay, so that is how ellipse is operate. Now let me just talk about the case of the ellipse. Here we have talked about. With the generator, the plane is not the slicing plane. What I have talked about? If the slicing plane is not parallel to the generator and it cuts only one nape, then it is ellipse. If it cuts both the napes, then it's hyperbola. And if the slicing plane, let me write here. If the slicing plane, okay, is not parallel to the, let me write here, is not parallel to the generator. Not parallel to the generator. That I have written down here. That I have written down here. Okay, now if it cuts the two nape, that is another point, is not parallel to the slicing plane, is not parallel to the generator, then it is a ellipse. Then it is an ellipse. If it cuts only, if it is parallel, cutting only one nape, parabola. If this slicing plane is not parallel to the generator, then it is forming an ellipse. Now if this is not parallel, no problem, but if it cuts both the napes, then it will give us hyperbola. It is not to the generator, then it is an ellipse. And if it cuts the two napes of these two napes, then it will obtain hyperbola. Then two napes, then a hyperbola will be obtained. This is hyperbola we have obtained, and hyperbola will be obtained. This is a basic information regarding, because of that they are known as conic section. So this conic section, this cone is sliced by a plane figure of plane area, and then it cuts a shape of a parabola. Now, what is the definition of parabola, ellipse and hyperbola? That let me now talk about. So ellipse and parabola and hyperbola. What is that ellipse? Now first parabola. To the section they are conic section known as first parabola. How parabola is obtained, that I have just talked about. But parabola definition, basic definition. If it is a path of a plane, let me write here. Parabola is a path of a point which moves in such a manner, this is under definition, it's in such a manner that its distance from a fixed point is equal to its distance from a fixed line to its distance equal to its distance from a straight line. From a straight line, we can say, from a straight line, not a fixed line, but from a straight line. Simple. Now let me just define it. The fixed point is known as focus, of the parabola and the straight line is the directrix, is known as the directrix. Okay, so if I just take this is a straight line here, and this is a parabola, let me take, and here is a fixed point. Okay, so let me take this. This is the fixed line here, and I've taken here its vertex. This is another point. So its distance, suppose this is the point here, let me take a point here. So its distance from a straight line, this is a straight line here, but this is Z point here, this is S point, focus point, SA, let me take. If I join this point to this point, this distance AS equal to, let me take here, T. AT is equal to AS in this case. Okay, so AT here, AS equal to AT. Okay, so this is a parabola. This is formed as if this is focus here. This is point focus, and this is bit about this point. Okay, so all this we will talk about when I take the questions. Okay, this is parabola. Ellipse is obtained. Again, ellipse is just a closed figure in which two focuses are there. This is central point. It has two major and minor sides here. This is A, B and B. Okay, and this is a focus point F. This is F1. Let me take, this is F2. Two focus points. Okay, so this is what we take, that the distance of a point is having common ratio. This is known as eccentricity. What is eccentricity? This is the ratio from a fixed point and from a two fixed point in this case. So this distance in this case, E is equal to, we have E is equal to AS upon this. E is 1 here. This is AS upon AT. This is equal to E. Here, if E is 1, this is known as parabola. If E is less than 1, this is ellipse. If E is greater than 1, hyperbola. So hyperbola and ellipse we will talk about later when I take the questions. Now let me stop it, because after 5 minutes I'll take, because camera is over. Camera is full. After 5 minutes I'll take this later. Only a bit information more is required about hyperbola and ellipse, that I'll take after 5 minutes time. Okay, that's it.